Welcome to my APM 3.1 video series. This is the first video in a short series that will dovetail into some previous videos that I've done that will walk you through every step you need to take this APM 3.1 board to be fully configured and tuned and optimized for your craft. We're going to install it into a quadcopter here. I have a 330 class quad that's been flying on a KK 2.0 for a year or two, and it's about time it had a slightly more intelligent brain to allow it to be used for FPV and mission flying as well. So this board, the 3.1, is the newest version of the APM. It's very small, it's only about 35mm side to side, with that 30mm mounting holes. It'll still have to be mounted on an anti-vibration pad, which we'll do in the next video, but the challenge that you've probably already spotted on here is because the board is so small, there are no 3-pin connectors like you have on the KK multi-wii or APM board. It's similar to some of the other smaller form factor boards that are coming out at the moment, where you have to make your own wiring looms up, which is part of the challenge and fun of the APM 3.1. The connections on the board, if we just go round it, are pretty straightforward. You have the USB connector, then at the bottom is the connector for the receiver, then the analog ports, then the connector for the power module. At the front is the connector for the ESCs. On the right above that is the connector for the GPS. If you flick it over on the back, there's the connector for the telemetry module on the Minim OSD. So what we'll do is we'll actually, in this video, replace essentially the first video in the existing APM series that we've already got. So right now on the channel there's already 8 videos that take you through all the steps for the APM 2.5, 2.6. It'll also work on the 2.7 from Hobby King as well. And in those 8 videos it talks about installation, power, arming modes, then takes you through fail-safe setup, how to use log files, how to set up auto trim and auto tune, and finally an introduction to mission planning. So in these videos what I'm going to do is replace the first 2, installation and power, with 2 new videos for the APM 3.1. Because the wiring is slightly different, the way the power works is slightly different, and the way you connect it to things like the receiver and other bits and bobs is a little bit different too. Once we've done these 2 videos, then the others in the series, arming modes, failsafe, log files, auto trim and missions, are exactly the same for this board as they are for the other APM series. So in this video what we're going to first of all cover is setting up and flashing the firmware to the board using Mission Planner. So to do that we're going to need a PC and a USB cable, exactly the same as we would do with any other APM board. Once we've done that, we're going to configure the compass or the magnetometer. We're going to configure the accelerometers, teach the board what level feels like and some other bits and pieces. Then we're going to stop there for a second. We're going to then make the wiring loom up to connect this board to a traditional receiver. So it's going to connect to the throttle, rudder, elevator, aileron and auxiliary channel so we can control the modes. I'll show you the different options that we have to make up that wiring loom using the cables that we get in the pack. Then we'll go back to Mission Planner, we'll then calibrate the radio, and then once we've done that we'll connect the GPS, make a little bundle of bits and pieces, and then we're ready for the second video. And in that second video we'll talk about power, where we'll look at how we're going to power the board, how we're going to do things like connect up to the ESCs and do the final tests before our first hover. So in this one we're going to start with Mission Planner. But before I go on to the next step, let me say a very big thank you to banggood.com who sent me this APM 3.1 and the GPS board that goes with it. Thank you again guys for sending this, really appreciate that. The link to the APM board is in the description at the bottom, and just kind of a say thank you, I'm just going to keep these guys' logo up here on the right hand side for a little while we get into the video. So let's fire the netbook up and I'll show you where to download Mission Planner. So the first thing you need to do, if you haven't done already, is download Mission Planner. Now Mission Planner is the fantastic bit of software that you use with the APM to both install the initial configuration files, the firmware, set it up, and then to do funky things like Mission Planner. So to download APM, you go to planner.ardupilot.com, click on download, click on mission planner, and then right at the bottom of that page you'll find that there's a download button that will take you to the latest version. Once you've done that, then you can run it, and here we are, we're running the latest version as of the time I'm recording, which is the end of December 2014, and we're going to spend most of our time in initial setup. Now at the moment we can't see anything here apart from install firmware, other bits and pieces. We have to select the board that's been plugged in. Now I've already plugged my board in and it's automatically installed the drivers. It's on COM24. There she is, Arduino Mega 2560. The speed is normally 115200. We shall click on install firmware. It'll go and get the firmware list. We are going to put it onto a quad, obviously, so I'll click on quad. It'll ask me if I'm sure, I'll say yes, and then it'll detect a board version, then download the right file, the hex file from the internet, then it'll compile it, and then it'll start uploading the firmware to the board. Now, what's happened now on the board is the amber power light is on, and the kind of golden colour light in the centre of the board is pulsing away as the firmware goes up. So one of the things you can see here in this interface that I'll just talk about while that's happening is you can see all the different type of craft that you can fit the APM onto. The next series of videos I'll be doing with this board will be around Ardu plane, where I'll be fitting it to a wing, but you can obviously fit it to a land-based vehicle, a helicopter, tricopter, a Y6, octocopters, both in the octa-quad and in the standard octa configuration, as well as a hexacopter. This is new actually, this has only just started to appear, the antenna tracker 0.2, which allows you to actually follow the plane in flight. So we've nearly finished uploading the firmware. Once it's done, it'll read it back to make sure it's all good, and if it's all good then it'll reboot it, and then once it's rebooted we should see in the mandatory hardware here on the left all the things that we're going to do next. So here it goes, verifying the firmware. And we're coming to the end now of the firmware verification. It's taken probably about 5 minutes, much longer than it took to upload it to the board. So be prepared for this bit. Have a cup of tea or coffee ready to sip while you wait. To finish off the tour of this interface, at the top here we have a number of tabs that you'll start to play with as you get more into the board. Very quickly, flight data is where you can view the information of where the plane is. If you have a telemetry radio or Bluetooth connection to the craft, then you can actually see live what's happening. Flight plan is where you create mission planner bits and pieces. Configuration and tuning is where we'll go in one of the later videos. So we're just about to finish here. This is the warning that's going to tell me that as of this couple of versions ago, it now starts the motors automatically when the throttle's up. And it's telling us we must redo a compass calibration. That's fine because we're going to do that anyway. So now it's done. The board was rebooting. Then it will reconnect, and then we'll be able to continue with the setup. So now we're connecting to the board for the first time. This is good news that we can see the board here. Is all the information coming down from the APM 3.1. And when it's connected, we'll see on the left hand side now we have a lot of extra bits and pieces in the mandatory hardware. So the first is frame type. So let's do that first. It's an X configuration, which is fine. We have plus, we can do V, V-tail, H-copters and other bits and pieces. In the very early versions of the software, V and H weren't available. Now the next one we have then is the accelerometer calibration. Now in this one we're going to have to move the board around, so I'm going to set the camera up so you can see the board, so you can see what I actually do here to configure it. So for this next bit, what we're going to have to do is put the board in all these different orientations as part of the setup. And what I've done to help with that is I've just installed some of these PCB standoffs. We'll use them in the end to actually mount the board and the compass on top of the frame, but by popping them in now, it actually gives me something that's very easy to get 90-degree angles with very simply. So that's just a little trick for these boards rather than use set squares and things, which is easier on the bigger ones. Now on this, just so we're clear, this bit here is the front. You can see hopefully there's a very little arrow in the middle of the board, and that tells us what the front is, and we're going to have to keep track of that as we do the accelerometer calibration. The first thing we do is click on Calibrate accelerometers, and it says place vehicle level and press any key. So we need to press this down so it's level, click a key. Next one, it says place vehicle on its left. That is the front, so that is left. Click when done. Click it on its right side. I'm going to have to take it slightly off the camera here because I'm going to have to put it over the edge of the table for this because of the way the cable is, but that still works. Click. Place the vehicle nose down, which is like that. Click. Place the vehicle nose up, which is like that. Place the vehicle on its back, which is upside down, which is like that. Click it, and it says calibration successful. So now the board knows what up, down, left and right feels like, which is good news. Now the next thing we need to do is calibrate the compass. Now the compass is actually, I think it's on board at the moment. Because this is essentially a 2.5 board, it has the compass on the actual thing itself. We're going to play with the GPS in a minute and see if we can get an external compass working. To get the external compass working, we have to break a little solder track, which on this one looks like it's connected. So let's try and see if this will work. So we'll do APM with onboard compass, and we'll do a live calibration. Now when I click on this, what's going to happen is it'll open a little window with an XYZ axis, and I'm going to have to rotate this an awful lot. So let's see if it's going to work. Okay, the compass is definitely on board and definitely working. So we'll calibrate this one first, and then we might play with an external one in a later video. So I'm just going to do this in all orientations, and this is going to take a while. There we go, that's slightly faster in this version of the software. We'll say OK, and then we'll stop there because the next bit is radio calibration, and as you can see at the moment it can't really see anything on any of the links. So what we're going to have to do is make the cable up to fit into here, and that will then connect to the receiver. So let's stop here and we'll get the crimpers and the soldering iron out because it's time to make our first wiring loom. So as we already talked about in the video, part of the fun with this is going to be making off the ends, because it comes with a lot of little cables that fit into these connectors. Now the receiver actually connects into the bottom of the board. This is the top, so we have to make the ends off so that it'll fit into a receiver. Now there are three options that I'm going to talk about in this one, and then I'm going to use one to actually make up the wiring loom myself. But the first thing we need to do is talk about which of the connections do which thing. Now because the APM 3.1 is a bit new, a lot of the websites as I'm recording don't have great information on this, so I've done a little diagram to help talk it through. This output is basically the same pinout as the one on the APM 2.5. goes from in 1 at one end right the way through to in 10 at the other end. And as you can probably see, there's a power and ground to power the receiver coming out at one end, and these other 8 are the signal wires. So what we're going to have to do is make up servo ends to fit in. So here's the diagram I've done, and the reason I've used these horrible colours for the wire is for my own benefit really, because these colours match the cable that came with this APM 3.1. Some of the cables that I've seen advertised online already come with some ends on them so that you can push them onto the individual pins on the receiver. I haven't got that, they're bare ends. So the way I'm going to have to do it is I'm going to have to connect the aileron to the first wire, elevator to the second, throttle to the third, rudder to the fourth, and auxiliary 1 to the 5th pin, which is the mode pin. And then I'm going to have to use the plus 5 volts and ground to connect to the receiver to power it, because that's a 5 volts out on the APM 3.1. If we were lucky enough to be using a CPPM receiver, it's a lot easier to cable up. And what you do is everything goes in through the first pin. So all you need to do is put 3 wires together in a servo lead, or something that will fit on a servo connector. You need the in 1 on one side, you need power in the middle, ground on the other side, and then you just connect pins 2 and 3 on the outputs. Just strip the ends of those cables off and put a blob of solder on them to connect them together. And then basically you're good to go with CPPM. Unfortunately for this one, it's an older Spectrum receiver that's on the craft, and I'll do the CPPM in the next version of this series where we'll put it on a wing. For this one, we'll do it the hard way. So what I'm going to do is I'm going to tin and fit on the end of each of these wires a connector. So let's look at the options that we've got to do this. So the first option that I figured out is we could actually just take an existing servo lead, cut it, strip it back, and then solder the wires individually onto the ends of the leads from the APM 3.1. That would work. That would give us a nice servo connector that we could pop in. It's going to mean an awful lot of waste, and soldering connections in the middle of a link is not a great idea in my experience, because the solder will, particularly with the vibration on something like a quadcopter, be under a lot of stress and can crack and fail. The next way we could do it is using these Arduino headers. Now these are the headers that you can get, they're dead cheap from places like eBay, Banggood and others, and the way this works is you can actually snap these pieces off or cut them, and then you can solder to the pins. So what I've actually done is from this bit is cut a 3-pin section off, and that fits into the servo connector on the receiver, and I can then solder the wires onto the back of it. Again, slightly more elegant than the first way, but still not perfect. And because these things are not really designed to go in servo connectors, they're a little bit short, because you can see I'm struggling to get it back out. The way I'm going to do it, I'm actually going to use a crimping tool. So on the first 5 wires and the plus and minus, I'm actually going to crimp the ends on, and then put them into a servo block. Now to do this, you actually are going to need a specialised servo crimping tool. This is a really cheap and cheerful manual one. There are automatic ones. I'm a bit old-fashioned in that I like to feel the resistance from whatever I'm crushing. And what we're going to do is to snip each of these off this runner. We're going to put the end in, and we're going to crimp it down. So let me put the crimped ends on these leads, and then we'll come back and we'll make the servo connectors up and plug it into the receiver, and then we'll plug it back into Mission Planner to check that we've done everything right. Okay, so I've just spent a happy 5 minutes crimping all the ends on, and now we're going to make up the cables to get plugged in. Now interestingly, one of the things I noticed as I was crimping the ends was that the black and red wires on this cable don't actually correspond to the plus 5 and ground out So I've just double checked this with the voltmeter with the APM connected to the PC, and yep, my suspicions were correct. The way it works on this is the very last wire is actually ground, and the second to last wire is plus 5 volts. So that is plus 5 volts, the black wire is plus 5 volts, and the red wire is ground. Be very careful of that when you are putting yours together. Putting these the wrong way around could have spelled disaster for the board, the receiver, or potentially both. So what I'm going to do is start plugging these into the ends now that I have all the bits and pieces on. The first channel on this little receiver is throttle. So I'm going to make the throttle channel up with the signal plus 5 volts and ground on the connector. And then I'm going to use another connector. So there'll be one on there like that. On the next 3 channels, it's aileron, elevator and rudder. And I'm going to connect the 3 next ones like that. So I'm just going to plug it all in as per the diagram. And the last one is the auxiliary signal, but I'm just going to put some heat shrink around that. Or I could potentially put it in another servo connector. I'll see how I feel. So let me just do that and we'll come back and have a look at how I've connected them. So here it is now plugged in. So the way it works is we have the 3 wires going into the throttle channel, the blue, which is the throttle signal, the black going to the plus 5 volts, and the red going to the minus 5 volts because for some wacky reason that's the way the cable's set up. And then going along the side now, we actually have the aileron is the muddy coloured, elevator is like a slightly purpley grey, rudder is green, and into auxiliary 1 is my mode. So the next thing to do, let's plug this back into the mission planner, bind this to the radio, and just make sure that that all makes sense and I can see all the channels moving in the right way for mission planner. So let me connect this up to the trusty netbook and let's check. So here we are, we've connected back to the computer, plugged in the USB cable. We're going to go back into the initial setup and make sure that we have the right COM port selected and click on connect. So this will open the port and then download all of the data again. Now what I've done here is I've actually just confirmed that everything's working. And what we just need to do is to make sure that all of the directions of each of the channels is right, and also use the sub trims to make sure that the middle values are as close to 1500 as we can get them. So now we've connected, we go to mandatory hardware. We've done compass, was the last thing we did before we paused. We go to radio calibration, and now wonderfully we can see all of the values coming through. So to prove it all works and we've got the right bits connected to the right thing, there is the roll, here is the pitch. Now the pitch at the moment is backwards, but we'll fly it and test it just because on the previous version of Mission Planner it had to be this way for it to fly okay. So I will double check that and put a note at the end of the video so which way it works. There's the rudder and throttle. So all of the channels that we've connected are working perfectly. Now we can see that the middle values, I've already been through and used the sub trim menus on the radio, so that the middle values are settling as close to 1500 as I can get it. The last 2 things I'll show you, you can see that channel 5 is on my 3 position switch. That'll allow me to set the flight modes, which is next in the menu. And I've also connected input 7 to the gear channel, just because that's useful when you want to do auto trim and auto tune later in the series. So now we know that everything is right, we will click on calibrate radio. It'll say ensure your transmitter is on and the receiver is powered and connected. Ensure your motor doesn't have the props connected. It isn't connected to anything at the moment, so that's fine. It'll say click OK and move all RC sticks and switches to extreme positions so the red bars hit the limits. So now what we need to do is carefully move each of the sticks to their furthest positions, and the easiest way with the sticks is to go from corner to corner. Similarly with the rudder and the throttle. hit the other switches that we were looking at, the gear and the mode switches. Once we've done that, we say click when done. Ensure that all sticks are centered and throttle is down. Click OK. And we're done. Completed. So the last thing I'll show you very quickly is flight modes. Using that 3-position switch, I've actually set it so that the bottom position is stabilized, the middle position is auto, and the top position is return to launch. For details on how all of this works, please see the later video in the series that talks around the flight modes in much more detail. Okay, so we've come to the end of this video. It's quite a long one, this one. What we'll do now is we'll stop there, and then when we come back in the second one, we'll do the power. We'll also connect it to the motors, do the final assembly and connection of the bits and pieces, and then we'll test fly it. Thank you for watching. Please like, subscribe, and happy flying.